folks, how you doing? And welcome to our study of the different researchers for the promotion of healthy living for seniors, along with looking at a couple of variables to increase one's quality of lifespan as you mature, as you get older. Okay, so recently I was taking this course. Just finished it yesterday, just took the final exam. It was called Aging, Decision Making, and Mobility. And we took an in-depth look at seniors, people who are older, like around 60s and older, and on just the different things that happen in their life that are pretty much inevitable, that we can either slow down through practicing good habits, or just have more of a knowledge of, so that when you are getting older, you can live a happier, happy-go-lucky life and not experience a lot of the maladies which the majority of seniors do as they get in their 60s plus. So the total intention of this video is just to help you live a happy lifestyle with your family, with your friends, to have that physical ability to move around, to be stronger, to be more confident, to feel happy in your life. Okay? So, who doesn't want to live healthier? Who doesn't want to, walk around as opposed to being in bed and hurt and not having enough energy to do any activities? Practically no one. Pretty made up this little board, and as we see here, we have researchers, and we all want to live healthy, seniors, healthy living, prevention of disease. Now I'm going to speak about some things in a senior's life which are inevitable. Some of them aren't, but a lot of them are. Our body declines as we age, certain systems in our body. So I'm going to point out different researchers within the last about 5 years, the main researchers that have done some really nice studies in the art of studying your breathing, your mitochondrial dysfunction. Mitochondria is the part in our body, in each cell, that regulates the oxygen that we breathe in and gives it out to provide energy, combining with food. Combining the oxygen with food to give energy, as we call it ATP. The deterioration of this and how we can slow that down. Sarcopenia is known as basically muscle death. As muscle dies when we get older, it happens. All of our muscle doesn't die, but a big portion of it, especially the muscle that is strength and power, and the ones that we need for quick reactive ability so that we don't fall down or we don't get hurt and break bones. Dementia, which is known as a big loss of your critical thinking, short-term memory, the ability to make decisions, to speak words and know what you're saying and to be coherent, to be able to remember names, to be able to assign meaning to something that is happening. A guy snatches a purse from a girl. That's a bad thing. I can at least assign meaning. Somebody with dementia may not be able to do that. Speaking in terms of experiment, it is a loss of the firing of the neurons, the acetylcholine in our brains, which give us a higher awareness of what's going on. Now, as we see with people that are manic, they have a lot of neurons that are firing all the time, so they're even more aware of the surroundings than we are, and possibly sense things that we don't. We just have a normal population that's within a certain degree of what we sense based upon how much our neurons fire. And with dementia, it's much less. As we see with Alzheimer's disease, Parkinson's disease, you could go into the neurological disorders of bipolar, the downside of it, schizophrenia, some anxiety disorders, Okay? And then the last one we look at here is stability, balance, and postural control, and how important that is no matter what age you are. We're always constantly balancing. I'm balancing right now sitting upright on this chair. You're balancing wherever you are. It's just to what degree are we balancing, and we start to notice the decline of our balance as we age. And it becomes a very important thing later on. When we're young, we don't notice it as much. So, what I'll do now, after explaining these, giving you a general overview, I'll talk about some of the latest research with the authors and their findings. Let's take a look at mitochondrial dysfunction. That means that there's a deterioration of how we are using oxygen in our system, combining with food to provide energy. Basically to move and to act with the oxygen usage in our body. Now, as we see with this study from John Duckett called The Normal Aging, he took a look at the matter in our brain. We have this white and gray matter which dictates our cognitive thinking, how we think, and our short-term memory, our long-term. And as we saw that with age, our gray matter and our white matter becomes less dense, and we have a less ability to critically think. He also took a look a lot into seniors and into the future with Social Security, Medicare and Medicaid, and some of the budget crisis that is going on with that. Being that the average senior in the year 2000 basically collects about $8,000 after paying out medication for Medicare and Medicaid, SSI. While the average person who works, who's aged 20 to 64, there's not as many people as there used to be in the past. There's a lot less working class now. And they are collectively paying out in taxes about $6,100. So there's an imbalance, not as many people working, and a lot more people that are seniors. A lot of baby boomers, a lot more people that are seniors now, and they're living a lot longer due to our advancement in technology, MRIs, CAT scans, X-rays, just the whole quality of living. We've raised the roof another 30 years in the last 30 years. You can live a lot longer. So there's supposedly a projection date by the year 2019 that these services will not be here anymore, Medicare, Medicaid, things like that. So one of our questions in class was to come up with a proposition of what we should do. Since we've done these studies, we see that there is a way to improve our quality of living as we age through exercise, through nutrition, eating your greens, your vegetables, not eating too much, but yet eating frequently, 5-6 meals a day. And through these practices, we can live a lot longer and getting your recovery and your sleep. David Hood, in his paper, The Coordination of Metabolic Plasticity in Skeletal Muscle, he took a look at mitochondrial biogenesis. And what that is, it is an explanation of how we use oxygen in our body to give energy so that we move and we move. And we took a look at each one of these intricate things in the body and how we are able to produce this energy and how it deteriorates with just maturing. And also, we found that through physical inactivity and eating the wrong kind of calories, a lot of simple sugars too much, and lots of saturated fat too much, it deteriorates. Okay? To give you a brief overview, when I do this, any kind of muscle movement, calcium releases into the muscle. And furthermore, calcium and something called AMP kinase and CMK kinase travel into the neuron of a cell where this thing called PGC1 alpha, which is very important in our body, it is activated and it replicates itself and it innervates these other particles, sensory pathways, basically called NRF1 and NRF2, which innervate a code that a decoder that transcribes code, DNA, which is our genetic makeup. TFAM describes that code, the DNA code, while NuGem, that's NRF2 is innervated, which is NuGem, is the 13 mitochondrial proteins in our body that will help us, and it's the 5 enzyme complexes that will break through the oxygen and with the proton will basically help us give that energy. Sounds kind of complicated, I know. But I'm giving you a brief overview. So as these travel down that cell, they go into a thing called PIM, proton import machinery, and they travel into another cell, into the mitochondria. And there, the DNA code is transcribed. And so it gets the information of the DNA code. And as it travels out of that mitochondria, it is now going to build another cell. And it's either going to become a big cell or it's going to divide into two. It's called fusion or fission. And from there, this thing called UPC3 will then basically increase this thing called reactive oxygen species. And what that is it's an imbalance in those 5 enzyme complexes, especially number 4 to 5. And it gets balanced out from 4 to 5 when a protein comes from the outer membrane and comes inside the membrane of that cell. Because it was unbalanced because the proton came out and then it goes back in, which is basically a hydrogen. You know that whole thing about chemistry and hydrogen and how important it is? This is one of those situations. So, basically what happens is ATP, after that enzyme complex happens and the proton comes back in, energy is given off, and we're able to give that energy and move and run and pump weight and lift groceries and throw the newspaper and move our mouth. And along with that, also apoptosis happens, and that is a good thing that the body does. It kills off cells that should be killed. They're kind of like weird cells in the body that just don't make sense and that could deteriorate us. As we see though, as we age, our body starts killing off good cells. That's called protein degradation. And that kills off some of our strength and power because then it starts killing off the type 2 fibers, which are the strong muscle fibers. Ian Lanza did a study where he took a look at 4 different groups of people. This had to do with endurance exercise. And 2 of the groups were young people that exercised and young people that pretty much never did. And old people that exercised and old people that pretty much never did. He took a look to see if the insulin resistance in older people was attributed to basically to physical inactivity or just a deterioration of our systems in our bodies as we age. He also looked at fat oxidization, whether we burn off less fat, if we burn off less fat due to aging, or is it just physical inactivity? He also took a look at mitochondrial dysfunction. And as he looked into mitochondrial dysfunction, he said, is our breathing problems because we're aging, or is it because we're physically inactive? And what he came up with, his research, was that the insulin resistance with the type 2 diabetes in our population and things like that, as we age, is basically based on physical inactivity, especially as we age. It's not dependent because we're just aging. it's because of physical activity. Though our breathing problems are due somewhat, a lot, attributed to not exercising, physical inactivity, but some of it is definitely attributed to aging. We deteriorate our breathing efficiency in the mitochondria of each cell in our body due to aging. So we point that out. Holcomb did research in aerobic training reduces brain tissue loss in the aging. And he took a look at how the gray matter in our mind, again, similar to John Duckett. John Duckett did an overview. Holcomb saw that there was less reduction of gray matter when you trained aerobically, like going for a walk or going for a slow jog, bicycling, swimming slowly, things like that. Something you can do for 15 minutes in a row, the same repetitive movement, using the major primary muscles underneath the lactate threshold. What is a lactate threshold? It means when you're not exerting too much energy and you can sustain it for 15 minutes or more, under 70% of your heart rate max, basically. Okay? Then Erickson and Kramer did two studies. One study dealt with an overview of looking at populations who are aerobically training and anaerobically training. Basically toning and stretching versus just walking. And they found that in a 6-month study, that when we start something or stop something, when you start one direction, stop at another direction, or change direction, aerobic training increases the reaction time of your ability to start, stop, change direction more than anaerobic. And anaerobic would be strength training, would be toning, shaping. So walking and jogging does better, slow jogging. Though they saw with a combination of both, that was the most superior, aerobic and anaerobic. We go into the cortical plasticity of skeletal muscle in the aging with Erickson and Kramer again, and we see they took a look at basically how physical activity stimulates brain function, how we're going to think more critically, how we're going to, our mitochondria in our cell is going to be healthier and more robust. And that's what they saw with that study. Now, as we go into sarcopenia, there was a guy by the name of Rubinoff who did an experiment called sarcopenia and its implications for the elderly. And he basically did an overview and saw that sarcopenia is the death of muscle. And when you have, quote unquote, 2.5 times your amount of muscle less than when you did when you were 20 to 30 years old, that's basically sarcopenia. 70% of your muscle lost between your prime years of muscle mass, aged between 20 to 30. In the USA, for people under 70, we are at approximately 13 to 24% as of the year about 2000, those diagnosed with sarcopenia. Now, as we go over the age of 80, over 50% of us have sarcopenia. What are some of the implications of this? We see that our central nervous system, our spine and our brain, decline a lot in their ability to just work. We see that our ability of muscle contraction function, to contract muscle and movement, lessens. We see that the gonadal steroids in our body lessen, are basically our hormones in our body. And we also see that what we call catabolic mediation, which is how the body starts killing off cells and killing off good cells, which we don't want, is increased when we're sarcopenic. Okay? Ian Jansen did a study on the healthcare costs of sarcopenia in the year 2000. And through national surveys of basically looking at just the disability portion of our population, they took a look at how much sarcopenia impacts our budget. Now, mind you, that's just the disability portion. We could have taken a look also at the obesity portion, at the overweight, at the osteoporosis portion, and a lot of other portions, type 2 diabetes, where sarcopenia is. But they just looked at one portion, and from that one portion they found that there was $18.5 billion accounted for people with sarcopenia. That's 1.5% our healthcare expenditure. For every guy, that's $860 that has it, and for every woman, that's $933. And as we also saw, they saw that a 10% reduction in sarcopenia would yield us a savings of $1.8 billion. Now, as we go further into this, if we were to look at the impact of sarcopenia and what it has on obesity, overweight, type 2 diabetes, higher predisposition for heart disease, cancer, not to mention all the emotional, neurological stuff with it of depression and more anxiety, we're looking at something that could be in the trillions of dollars. Next one, Keith Barr did a study on the signaling underlying fitness. And from there, he took a look at basically what makes somebody strong and powerful and have a lot of hypertrophy, and what makes somebody more of the endurance type. And how do we stimulate strength so that one can get strength more easily? What variables? So he named 3 variables. Here's what they are. Load, which would be the weight, the amount of weight you're using. Metabolic stress, which I'll generalize as throughout your whole workout duration, what level of exertion are you working at? Okay? I might be a little bit wrong in that definition, I apologize. And calcium flux, how much calcium is released into the body for this specific exercise in the total. And as he saw, in order to increase your muscle mass, to increase as much as possible your hypertrophy, your broadness, to increase your strength and your power, you need to increase mTOR in the body and its phosphorylation activities. You need to increase this to stimulate your anabolism and your testosterone to really shoot up. How do we do this? By having a high load, which means having heavy weight, or basically heavy weight, or performing the exercise really slow in the toughest part so that you can't last too long, along with having low metabolic stress and low calcium flux. So basically in a short amount of time with a lot of rest break. That's what it means. Okay? Because of metabolic stress, you look at 5 minutes. Well, if for 30 seconds you're all out, and then for the next 4.5 minutes you're doing nothing, it looks like low metabolic stress. Okay? Versus if you were running a marathon, then you would constantly be exerting energy, which would be a high metabolic stress. Okay? Or bicycling. Okay? Because you're constantly exerting energy. But if you're working with strength and power, then you're taking a lot of rest breaks. So that's low metabolic stress, low calcium flux, and high load. Okay? And they saw with an endurance phenotype that you want a low load and a high calcium flux and a high metabolic stress. Elaine Volpe, I believe, well, I know her last name is Volpe. I think it's Elaine. But she did a study on essential amino acids are primarily responsible for amino acid stimulation in muscle anabolism. Basically, she is taking a look at the proteins in our body that are not in our body. They're called essential amino acids. There's basically 8 to 10 of them. 10 of them when we're young, and 8 of them as we mature past the age of 18 that we supposedly need in order to build muscle and repair muscle tissue and survive. Private Tim Hall, phenylalanine, vanillin, tryptophan, threonine, isoleucine, methionine, histidine and arginine are for the youth, and leucine and lysine. Leucine is the most anabolic amino acid that the body doesn't produce. So that's big. It's big among bodybuilders. But those are the 8 amino acids, actually the 10, that our body doesn't produce. So what she did is she got a study and took a look at a group of 6 people that were taking 18 grams of just essential amino acids, and she took a look at 8 other people, 8 other guys, same age, that were taking 18 grams of essential amino acids and 22 grams of amino acids that were not essential. Basically, 22 more grams of protein that were already the proteins that are in our body. And what she saw was there was no increase in muscle growth. We call that protein synthesis, by taking all those additional proteins. So, if you're older and you're supplementing with protein, she saw from this study was done so that people that are older that are supplementing with protein, that they just take the protein supplements that have essential amino acids, as opposed to other proteins that may not have the essential amino acids. Now, usually, from my knowledge, most supplements of proteins have the essential amino acids, but you'll want to check and make sure, okay? And they're just now starting to put, the last year or two, EAA, which means essential amino acids, whole new thing. So you want that if you're older and you need more protein, because as we age, we need even more protein, 1 to 1.5 grams of protein per kilogram, which is 2.2 pounds. Usually an adult would need just 0.8 grams of protein per kilogram. Dirks with the mitochondrial DNA mutations in energy metabolism and apoptosis. And he just took a look at basically the manipulating factors in our body that bring a deterioration and a decline of the oxygen usage with the energy output, that's the mitochondrial dysfunction, along with sarcopenia, and how our metabolism becomes lessened because we're not working at the same level. Our deterioration in our mitochondria and our muscle is we have less muscle. So our metabolism is less, and therefore our body is killing off even more cells and more fast twitch fibers that we need to use this muscle and when we fall, so that it doesn't hurt as much, we don't break bones, and so that we're stronger, we can lift weight, we feel better. When we feel better mentally, emotionally, we will be better. Mental into the physical, emotional to the physical. Adam Johnson took a look on a study called Resistance Training, Sarcopenia, and the Mitochondrial Theory of the Aging. And from there, he basically sought that with especially strength training, that it lessens the extent of sarcopenia, the dying off of muscle, and it also lessens the extent of the aging in mitochondria, so that we can live longer, live more quality, and tied it into with the brain, how the blood circulation in our brain improves, and we even build more neurons, more brain cells in our body. We have more DNA to give code and give individuality and initiate more detailed movement with our fingers and arms and hands, more controlled. So we saw a lot with that. Gibala did a study, forgot exactly what the title was, but it took a look at subjects training with this leg exercise. It's very strenuous. We call it the Wingate test in exercise science. It might not have been the Wingate test, but it was just like it. Very similar. And it was 30 seconds of all out pedaling hard on a bicycle that has weight on it. So it gets real tiring because it tires out your legs and your butt, your glutes, a lot. And they did that for 30 seconds, took a 4-minute break, and did it again. And they did it 4 times. So they effectively exercised for 2 minutes. 30 seconds, take a 4-minute break, 30 seconds again, take a break, 4 minutes, and again and again. And they had another group who did aerobic activity for 45 minutes. And what they saw was the one that did the Wingate test improved in their cardiovascular endurance just as much as the other group did. And they even were able to improve their muscular endurance, because that is all strength and power there, pedaling as hard as you can for 30 seconds when you have heavy weight to pedal, really heavy. And so that was pretty interesting to see that you can get cardiovascular and muscular endurance all in one without having to go on a boring cardio for 45 minutes. Now, don't get me wrong, there are advantages to going on a cardio for 45 minutes, I believe. But I'm one of these two who would rather conserve time, and I like to be a strength power guy just the same. As we age, it is even more important to get this strength and power because we lose it in our type 2 fibers. Stability, balance, and postural control. Took a look at this guy called Gotthard. He did 2 studies. First study was his influence of proprioceptive and bioenergetic physical activities on balance and control in elderly women. Basically, he had 3 groups. One group trained proprioceptive exercise. That is with basically yoga and soft gymnastics. The second group was bioenergetic. That was cardiovascular endurance with swimming, jogging, bicycling, 1 to 2 times a week. And the third group was a control group. They just did walking. They wanted to see which group would maintain the most balance and control in their movement with their testing equipment. And it was the proprioceptive, the one that trained yoga, soft gymnastics. Tai Chi would also be something that they would do too, that you could do that would be very similar, Tai Chi. Okay? So they had the most stability, balance, and postural control with that. Bioenergetic activities did second best. That was swimming, jogging, and bicycling. And walking was last. Those were the walkers. So as far as retaining your balance, postural control, stability. In his last study, he did the physical and sporting activities in the vestibular afferent usage in balance in older adults. And basically there was 2 groups, 18 in Group A and 18 in Group B. Group A did the bioenergetic activities, and Group B was just walking. Which group performed better in balance? Bioenergetic, which was, in this specific time, I believe that incorporated some Tai Chi, but was also of the swimming and the jogging and things of that nature. So we see here as an overview through our studies that it's very important to have these type 2 fibers when we age, because they're going to help us to regain balance and quickness of movement when we need it. So we don't fall, we don't hurt ourselves. So we have that strength to lift the things we need to do, to take care of ourselves, to groom ourselves. Very important. Along with a less of a decline, by having these and improving the strength will increase the blood circulation in our brain, have less of a decline in the cortices of our brain, improve our ability to use oxygen as we yield energy, and our nervous system will be increased. We will have better efficiency and transmission of signals from our spine to our brain to our muscle fibers to the joints in our body to manipulate movement and coordinate it in an efficient manner. And we see that with high intensity training, it can be advantageous when we're older to train, with a higher load. This would be under, supervision of a personal trainer and with a doctor's consent to train with a higher intensity. If you're a beginner, start out slow. I have my own clients and I start them out slow, but eventually by increasing their strength and even increasing sometimes lifting weight heavier, faster, this is when they're pretty decently trained, like a year or something like that. That's by my standards. By their standards, they want people to start working like this fast, like fast, with fast movement. I'm not so much the type like that because I know how out of shape people are and I know that they need to adapt. And to be able to get somebody to act like they've been training for 10 or 15 years, kind of ridiculous, I think. But that is the most advantageous, to train with higher speed and velocity. And just to live with longevity of life, to eat better nutrition, eat your vegetables. This is NutriPoint Systems here, and it shows that in this point system, right here, increasing our longevity of life, vegetables by far, I mean, they kick the tail off fruits, off grains, off beans, off milk, off meat. They kick the butt off of this stuff. So what you need to do, if you want to get rid of cancer, if you want to freaking have less chance of heart disease, is eat your freaking vegetables. Eat your spinach. I'm going to read it in order of precedence here. Spinach, broccoli, lettuce, asparagus, cauliflower, Brussels sprouts, cabbage, carrots, lettuce, mushrooms, okra, tomato, radishes, squash, green beans, and cucumber. They are so important for the real nutrition that our body needs to, just be healthy and live, from what we found. The Okinawans in Japan, they live with a lot of greens, eating a lot of greens, not eating much, very low calorie, and a lot of them live around 120 years old, easy, no problem, no questions asked. Okay? So, that's about it for today. As a personal recommendation, eat your good food, exercise, live a happy life, build happy, emotional, strong friendships and relationships that you look forward to being. Enjoy life and congratulate yourself and take time to appreciate what you've done in this lifetime. I thank you for allowing me to be your host, and you're living 15, 20 years longer with a higher quality of living, and being here as a real person and to be there for other people. Thank you. God bless you.